Welcome, everyone. I'm excited to kick off our journey into the fascinating world of physics. Today, we're exploring mass matter, where curiosity meets physics. On this first slide, I just want to warmly welcome you all and give you a quick idea of what's ahead. We'll be delving into the fundamental concepts of matter, uncovering how curiosity drives scientific discovery, and seeing how physics helps us understand the universe around us. So, let's get started and enjoy this fascinating exploration together. Let's talk about stars. They are giant, glowing spheres of hot gas, mainly made up of hydrogen and helium. These elements are fundamental because they make up most of the universe's visible matter. Now, stars shine because of a process happening deep inside them, nuclear fusion. In their cores, hydrogen atoms fuse together to form helium. This fusion process releases an enormous amount of energy, which we see as light and feel as heat. This energy is what makes stars shine so brightly and sustain their glow for millions or even billions of years. Understanding how stars produce energy helps us see the bigger picture of how our universe is constantly evolving and shining. Have you ever looked up at the night sky and wondered where do stars actually come from? Today, we're going to explore that very question and take a closer look at the cosmic nursery where stars are born. It's a fascinating process that starts deep within vast clouds of gas and dust, where gravity begins to work its magic. These regions are often called stellar nurseries because they're the birthplaces of new stars. As we go through this, remember that the universe is whispering its secrets, but only to those who truly listen with their hearts. Understanding how stars are born helps us connect with the bigger picture of our universe, how it evolves, how it creates the light we see at night, and ultimately, how it sustains life on Earth. So, let's dive in and discover the incredible journey from cosmic gas clouds to shining stars. Let's start with the fascinating beginning of stars, which is the nebula. A nebula is essentially a massive cloud of gas and dust floating out in space. Think of it as a stellar nursery, a place where new stars are born. Inside this cloud, gravity plays a crucial role. It gradually pulls particles of gas and dust closer together, starting the process of star formation. This initial gathering of material is the first step in transforming a simple cloud into a shining star. So, understanding the nebula helps us see how the raw materials of space come together to create the stars that light up our universe. Now, let's explore the next stage in star formation, the protostar. As the cloud continues to collapse under gravity, the center begins to heat up and become denser. This process leads to the formation of what we call a protostar. It's important to note that at this stage, the protostar isn't shining like a star just yet. It's still essentially in the womb, gathering more material from the surrounding cloud. This gathering process is crucial because it sets the stage for the eventual birth of a new star. So even though it's not yet shining brightly, this phase is a vital part of how stars come into existence. It's a slow, steady buildup that leads to the next exciting phase in our star's life cycle. Now, let's talk about the next crucial stage in a star's birth: ignition. When the core of a collapsing gas cloud heats up to about 10 million degrees Celsius, nuclear fusion kicks in. This is the point where hydrogen atoms start fusing together to form helium. And this process releases an enormous amount of light and energy, which is what makes the star shine. This moment marks the true birth of a star. It's the point where the star transitions from just a dense, hot core to a luminous object shining brightly in the universe. It's fascinating because all that energy produced is what sustains the star throughout its life. So, in essence, ignition is the pivotal event that transforms a mere cloud of gas into a shining star, connecting the dots of how stars come to life in the grand story of the cosmos. Now we move to the main sequence stage, which is really the longest and most stable period in a star's life. During this time, the star is essentially balancing the forces inside it, gravity pulling inward and nuclear fusion pushing outward. Our sun is currently in this stage, happily fusing hydrogen into helium. This process has been going on for billions of years, and it will continue for billions more. This stable fusion process is what makes stars like our sun shine steadily and provide the energy that supports life on Earth. So, when we think about the birth of stars, The main sequence is really the core phase where they spend most of their lives, shining brightly and maintaining that delicate balance. Let's take a closer look at some fascinating facts about stellar nurseries. One of the most well-known is the Orion Nebula, also known as M42. It's remarkable because you can actually see it even with small telescopes, making it accessible to amateur astronomers as well as professionals. This nebula is one of the closest and brightest stellar nurseries to Earth, which means we're witnessing star formation happening right in our cosmic backyard. Now, what's truly incredible is that thousands of new stars are being born within the Orion Nebula at this very moment. These regions are like cosmic construction sites, where gas and dust come together to form new stars. But how does this star birth happen? Sometimes, it's triggered by dramatic events like a nearby supernova explosion. The shock waves from such an explosion can compress the gas in a nebula, kickstarting the process of gravitational collapse that leads to star formation. Interestingly, even the radiation pressure from a nearby star can have the same effect, pushing and squeezing the gas until it begins to clump together. In a way, it's like a death giving rise to new life. One star's end can spark the birth of another. This cyclical process highlights how interconnected and dynamic our universe truly is. It's a beautiful reminder that even endings can be the beginning of something new in the grand cosmic cycle. Now let's look at some fascinating facts about star formation. First up, baby throw tantrums. Well, not exactly, but newborn stars do shoot out massive jets of gas at hundreds of kilometers per second. These jets create glowing shock waves known as hero objects. Think of them as cosmic fireworks announcing that a star has just been born. It's a dramatic and beautiful way the universe signals new stellar life. Next, when a protostar ignites, it's actually still buried deep in dust. By the time we see its light, the star has been shining for thousands of years. So, what we observe is really like catching the after-party, not the exact moment of birth. It's a reminder of how distant and time-delayed these cosmic events are from our perspective. Lastly, most stars don't form alone. They usually come together in clusters. Our sun is actually quite unusual in this regard. It probably formed in a cluster but ended up alone after drifting away. This helps us understand that solitary stars are the exception, not the rule, and that stars often have a communal origin before finding their solitary paths. All these facts connect back to the overall theme. The birth and early life of stars are dynamic, energetic, and often communal processes. More mass equals more matter. That's a simple but powerful idea. It reminds us that when an object has more mass, it contains more matter, which is the stuff that makes up everything around us. Understanding this connection is key to grasping how gravity works and how objects interact in the universe. So, as we've seen throughout this presentation, mass influences how objects behave and how they relate to each other. Thank you for your attention, and I hope this wraps up our journey into understanding these fundamental concepts.